Dear all, I am Dr. Senthilkumar. I would like to continue my Fins of lecture in the unit of conduction. Now let me see the extended surface. So, what is in the extended surface? In normal explanation, expanded surface is nothing but the surface which is having the more cross section area in addition to the regular area. That is said to be the extended surface. So, where we can see this extended surface can be seen in the IC engines. You all would have seen the IC engine where the engine is covered with the extended surface, which is called as fins. These fins are very good in nature of increasing the cross section area based on the design parameter. Based on the design parameter, we can design whether thin fins or thick fin or rectangular or square or whatever shape we want, whatever the dimension we want, based on the nature of heat transfer. Now let me see the extended surface here. So this is nothing but the extended surface T out. So T infinity is the ambient temperature as we see in the series of lecture earlier. So which augment the rate of heat transfer from the object. So how it augments? That is very, very important. So the additional area added to the increased surface area. We know that Newton's law of cooling, Q equal to HA delta T, where area increases, heat transfer also increases. So as we discussed, we can see here the heat dissipation to the surrounding. So throughout the circumference of the fin, this is a circular fin. Let me see one by one what are the shape of the circular fin, what are the other geometrical shapes are available. So say for example, T outlet temperature is 100 degrees centigrade. So T infinity will be 30 degrees centigrade, which will transfer heat based on the which law? Can you see anyone say? Yes. So which is based on Kelvin-Planck statement. Heat always flows from higher temperature to the higher temperature. So which transduces along the length of fin. So T reduces along the length of the when the length is increasing, which reduces the temperature. So when delta T increases, the length of the fin which is effective. Fin is effective. So when delta T decreases, fin is not comfortable, which is not efficient. It is not efficient, which can be reduced. So here we would like to say one-dimensional analysis for fins. So one-dimensional, let me see the Q array which is having the similarity of K fin Tc minus Ts divided by delta. So here these two parameters are nothing but delta T, the surrounding temperature and surface temperature, and delta is nothing but number of phase. So here same like T K fin which is equal to T naught minus Ts divided by delta, which is H delta T, which is nothing but the Newton's law of cooling which I have seen here. So coming to that equation, Tc minus Ts, Ts minus T infinity, which is nothing but H infinity divided by thermal conductivity of fin. K is nothing but thermal conductivity of the fin. So one dimensional analysis is possible if Tc minus Ts less than Ts minus T infinity. So H infinity divided by K fin, which always lesser than 1 based on the Bayes number. So Bayes number which is having the ratio of conductive resistance to the convective resistance, del Ka by 1 by Ha, which is nothing but conductive resistance, that is Bayes number. As I said earlier, let me see the different shapes of the fins. So this is nothing but the triangular fin, and this is also the small triangular fin, and this is a circular fin. So this is rectangular one is another is spline like corrective rectangular fin. So these three are the different type of fins we had seen in the class. In continuation that we can see the length, we can see its heat transfer, we can see its circumferential area, we can see the cross section area. Cross section area is an important parameter and the reason having more scope in increasing the heat transfer coefficient in case of fins. So with this small lecture on fins, I would like to close the session. Thank you very much.